It is a technology which can be used to measure the optical properties for the photothermal theranostics. So it's photothermal means we are using light and converting this light into heat, and this can be deployed for diagnostic as well as therapeutic applications, mainly for cancer therapeutics. So in the first case, the problem is that when we use laser or light for such therapy or diagnostic applications, we need to quantify the optical absorption as well as scattering. So there are few techniques available which can be utilized to do this, but here we are doing it for the real time, that is whenever there is an interaction of laser with the tissue or a substrate, at that time itself we are quantifying the optical properties. And so that's the main advantage of this technique, and we have also filed a patent on this. So we are using a laser for the photothermal effect. At the same time, we are using another light to detect these optical properties. So the novelty here is again the same, that it can be used for a variety of things apart from the therapeutics. It can be also used for various diagnostics which involve the optical phenomena or the temperature effects. And presently we have tested this technology through some phantoms which we have validated in the lab itself, and the TRL level is 4 to 5. Next we'll be going for the packaging of the device. No, it's like a bench type system we have available with us. And so there are a variety of applications where it can be used. One is the cancer therapeutics for plasmonic photothermal therapy, which means we are using nanoparticles and light to selectively damage a tissue. It can also be used for the photodynamic therapy to measure the optical interaction of the molecules with the laser, and any other applications which involve laser as well as the temperature, and also for some in vitro tests if these are there. The market is huge for the optical diagnostics and therapeutics in today's scenario, because these are non-invasive or minimal invasive, and the commercialization, again, it will be done as per the CSIR norms which are applicable for our institutes. So it will take about 2 years, as per my opinion, to take it to TRL 9, and there is no critical equipment or manpower requirement to adopt this technology. So from the industry, if someone is interested, we can discuss and then have the technology transfer as per the common guidelines available. Thank you.
So just for the veterinary presentations, when we are talking about the role of any diagnostic or therapeutics for the human diseases, the safety becomes a very important aspect. That is number one. Number two, whatever you have developed, it's fine, but that has to work on the body in reality.
Yeah.
Right? So before anybody will take up for its commercial production, these two things has to be answered upfront. So just producing a product is not enough as far as the medical device is concerned,
Yeah.
and that too when it is acting on the body in some way. So to reach to the commercialization, before that lot many other things has to be done.
Yeah.
So what is your plan to do those? Whether you are we are planning to do those things on your own or in collaboration with the industry, and you have to bring the medical professionals also into the picture as collaborator.
Exactly. So we are planning to take it up with the industry itself, because this is a sort of you can say specific application for which this technique was developed. So depending on the market assessment which can be done by industry professional, then we can take it up further when we have an industry collaboration with us. And obviously we will be going for the clinical trials, so there we can involve the clinicians. Because the market segment, we are not much aware of for this thing.